The second method we want to cover, which is really quite common and used in many different types of subsurface conditions, is the rotary drilling method. So the rotary drilling method is basically driven by the rotation of a drill string. And you can see in the diagram, the drill string is the purple section going down to the bottom, and that rotation is achieved by a hydraulic top drive. So the machine effectively just rotates a string of drill pipe, of hollow drill pipe, and an assembly which comprises a drill bit, drill collars, and stabilizers, which are all depicted in the diagram on the right. The rotary drilling methods generally break up the subsurface by a cutting bit action, and that cutting bit action is driven by the rotation on the surface, but more importantly, it is actually dependent on the weight that has been put on the bit from the surface. So it's a sort of a cutting and ripping rotating motion. The key thing to remember about this drilling method, it is generally has slower penetration rates than other methods that we will discuss. But the point here is that this method uses a drilling fluid to clean the borehole, cool the drill bit, and bring the cuttings back up to the surface, as you can see on the diagram on the right-hand side. The point of this system is that it is sealed and it is recirculated. The mud and the fluid is recirculated once the mud is cleaned. The depths that can be achievable are up to several hundreds of meters to all the way to several thousands of meters. Some of the deepest hydrocarbon boreholes in the world have been drilled using this particular method. The next method we want to cover is a variant of the method that we just discussed. It's called the dual rotary method, and it basically allows a lower rotating drive to spin steel casing at the same time as the drill string with the bit and the pipe on it. And the advantage of this is that it's a really useful method for implementing drilling operations in broken or unstable ground, because it allows metal casing to be installed simultaneously as the borehole is being drilled. So if you're in unstable ground, the borehole generally has a tendency to collapse or to close over as you drill it, and you need the steel casing effectively to support the borehole walls and keep it open. So it is particularly good in these unstable conditions. Its advantage is that it can be used with a mud rotary drilling system, or it can be used with a compressed air method, as we will discuss in a few moments. However, it does require a specific type of drilling rig. You can see there is lots more equipment connected on there, particularly a dedicated discharge for the cuttings, which you can see the red piled cuttings on the ground there, and a dedicated system for the air or mud system that you're using and swiveling the casing.